Hi guys, welcome back to my YouTube channel. In the last video we saw the simulations of a 4 bus electric power network inside the PowerWorld Simulator. In this video we will see the simulations of 5 bus electric power network inside the PowerWorld Simulator. So the system is having 5 bus bars uh, and the the loads are connected to bus number 1, bus number 3, bus number 2 and bus number 5, while the generating stations are connected to bus number 2, 3 and 4. As stated in the question that bus number 4 is the slack bus. The nominal voltage is 220 kV and each generator is generating the power of 500 megawatts, having the reactive power of 10 megawatts, and the capacity of each transmission line is 350 MVA. Uh, Moving further, the system parameters are such that the loads are having the following values. Load number 1 and 2 are identical, which are power uh, resistive loads. So the load number 3 and load number 4 the are having the active power 150 and 200 megawatt, while the reactive power is 50 megawatts. The transmission line parameters are given such that the transmission lines are represented from T1 to T4, as you can see in this figure. T1, T2, T3, T4 and T5. So these are my transmission lines. The parameters of the transmission lines are given as below. So let's go to the PowerWorld Simulator to simulate this system. Let's open the PowerWorld Simulator. Go to File, select New Case. So our file has been opened. Now inside the PowerWorld Simulator, first of all we must draw the 5 bus bar. So let's begin with bus bar number 1. Go to draw, go to network, select bus and put it here. So rename it as bus 1. Since in the question it is given that the nominal voltage is 220 kilovolt, so we need to provide nominal voltage as 220 kilovolt, and the orientation is right. The bus information is 1 plus J0. Click OK. So this is my bus number 1. Now again go to network, select bus, put it here and rename it as bus number 2. And as you can see that the nominal voltage is by default 220 as the previous one. So go to bus information and again select 1 plus J0. The orientation must be right, so click OK. Now there are 3 bus bars remaining inside the system. So again place bus bar number 3, rename it as bus 3. So click OK. Now bus bar number 4, rename it as bus 4. So click OK. And finally we should add the bus bar number 5, which is our last bus bar. So go to network, select bus and place it here. So rename it as bus number 5 and the OK. So since our bus number 4 is the slack bus, so we must select the bus number 4 as we must tick the system slack bus So click OK. Now the bus bars have been completed. Now we must add the loads. As you can see that there are 4 loads inside the system. Load number 1, 2, 3 and 4. So let's add the loads one by one. So since load number 1 is having a value of 50 megawatts and also load number 2 is having the same value as load number 1. The load to bus number 1. So this is my bus number 1. Add a load of 50 megawatts and the orientation must be up. So this is my load number 1. You can also rescale the load according to the given dimensions. So now add load number 2, 3 and 4. Now I am adding load number 2. Now load number 2 is having the same value as load number 1. So it is again 50 megawatts and the orientation is up. So select OK. Now we must add load number 3. So since it is having a value of 150 megawatts, so just provide 150 megawatts to the constant power and add 50 megawatt to the reactive power. So that's the load number 3. Rescale it. Now finally we must add the load number 4 at bus number 5. So again select load at bus number 5 and it is having a value of 250 megawatts. As you can see that it is having a value of 200 megawatts and 50 megawatts. So click OK. Now we must add the generators inside the given system. There are 3 generating stations in the given transmission system: G1, G2 and G3. Each generator is capable of generating the power of 500 megawatts and 10 megawatts. So we must add the generating units one by one. First of all, generator number G1. It is having a value of 500 megawatts and 10 megawatts. Now go to display and permission, select down and set the rotor shape as dog bone by default. So select OK. Now my generator G1 has been added to the system. Now add generator G2 at bus number 4, which is our slack bus. So 500 megawatts and 10 megawatts. Click OK and select the orientation as down and rotor shape as dog bone. Click OK. Now this is my generator G2 and now add generator G3. Since all the generating units are having the same load, same power output, so let it be as the previous generators. Select the orientation as down and click OK. Now we must add the transmission lines inside the given system. So first of all, let's rescale the bus bars so that we can add the transmission lines easily. Now, in the given question, it has been asked that there are five transmission lines: the T1, T2, T3, T4, and T5. So let's add the transmission lines one by one. So first of all, transmission line T1. Since the T1 connects bus number 1 and bus number 3, so go to network, transmission line, select bus number 1, and uh, now select bus number 3 and double click. Now, as we saw in the previous video that a dialog box will appear, so just click on calculate impedance from per distance impedances and select kilometers, click OK, and then since the length of transmission line T1 is 25 kilometer, the R value is 2 and the X value is 1. As you can see that it is having a distance of 25 kilometer, and the value of R and X are given as 2 plus J1 ohms per kilometer. So that's the transmission line T1. Click OK. Now add transmission line T2. Go to network, transmission lines, and now select calculate impedances from per distance impedance and then select kilometers. Yes, and the distance of transmission line T2 is 20 kilometers, and the R and X value are 2 and 1.1 respectively. So 2 and 1.1. Click OK. Again OK. Now transmission line T3. So go to network and select transmission line. Then go to calculate impedance. Then select kilometers. And since the length of transmission line T3 is 12 kilometer, so make it 12, and the resistance and the uh, reactance are 2.8 and 0.9 respectively. So click OK. Again OK. Now add the transmission line T4. So for that purpose, select transmission line, then repeat the same procedure as per the remaining transmission lines. So the length is 18 kilometers. The R and X values are 2.5 and 0.9, 2.5 and 0.9 respectively. So click OK. Again OK. Now finally we must add the transmission line T5. So go to transmission lines, double click, and select kilometers. Yes, and then the distance is 20 kilometer. The R value is 2.5 and the X value is 0.8 respectively. So OK. Now our transmission system has been completed, but before going to run this system, just add the MVA capacity of each transmission line. So we need to click on each transmission line and set the value as 350 MVA. So it is 350 MVA. Each transmission line is having capacity of 350. Always show value and the total power in MVA. So it will show the value of total MVA. Okay, so our system has been completed. Now go to run mode, go to tools. Now as you can see that the transmission line T2 and T3 has been overloaded because the MVA capacity exceeds the total MVA capacity of these transmission line. Now in order to study the parameters of this system, go to Model Explorer. So these are my parameters of this system. Now the red values shows that the value of the bus bar, the per unit value of the bus bar is below the allowable limit, which is 0.95 per unit. So in order to improve the voltage at these bus bars, there are several methods to improve the voltage. We can do that by adding the capacitors at these bus bars. So let's add a capacitors of 100 megawatts at these two bus bars. So bus number 1 is having a value of 0.87 per unit, and bus number 5 is having a value of 0.80 per unit. So let's add a capacitors of 100 megawatts to bus number 1 and bus number 5. Now go to edit mode, select draw, then uh, select switched shunt at bus number 1. So I am installing a capacitor of 100 megawatt at bus number 1 and bus number 5. The orientation must be up. So this is my capacitor at bus number 1, and also add a capacitor at bus number 5. I am adding capacitor of 100 megawatt at bus number 5. Now again run the system to observe the values of the bus bars. Now as you can see that the uh, value of bus bar has been improved from 0.8 to 0.90 per unit, but the bus number 5 is again showing the value of 0.84. So we must either increase the value of the capacitance that we have already installed at this bus bar, or we can install another capacitor at this bus bar. So let's install another capacitor of 100 megawatt at this bus bar. So again go to edit mode, select draw, switched shunt, and then add it at bus number 1. Oh sorry, we need to install the capacitor at bus number 5. So select bus number 5 and then add a value of 100 megawatts. So let's again run the simulations to observe the values. Let's go to Model Explorer. So again the value has been improved from 0.84 to 0.86. We can repeat the process until and unless we get the allowable limit of the specific bus bar. So let's increase the value of installed capacitor from 200 to 300 megawatts. Select switched shunt and add it at bus number 5. So I am installing another 100 megawatt capacitor at this bus bar. Now again run the system. Now the value has been improved from 0.84 to 0.87. We can repeat this process until and unless we get the allowable limit of the bus bar voltage. So that's all about the simulations of a 5 bus bar electric power network inside the PowerWorld simulator, and how to improve the power factor of a specific bus bar inside the PowerWorld simulator. So that's all. Stay tuned for my next video. Allah Hafiz.